Well, hello and welcome to Science Never Stops. I'm your host, Joseph Vick, the Museum Education Director at the U.S. Space and Rocket Center. Today we are celebrating NASA's International Observe the Moon Night, sponsored by the Planetary Missions Program at Marshall Space Flight Center. International Observe the Moon Night is a time to come together with fellow moon enthusiasts and curious people worldwide. Everyone on Earth is invited to learn about lunar science and exploration, take part in celestial observations, and honor cultural and personal connections to the moon. You can check out moon.nasa.gov/observe online and follow the hashtag #ObserveTheMoon on your preferred social media platform. Outdoors, at home, online, or wherever you may be, we're glad to have you with us. However you choose to observe, please follow local guidelines and health and safety. On today's program, we have Brian Day, Deputy Staff Scientist for NASA's Solar System Exploration Research Virtual Institute at NASA Ames Research Center. He also currently serves as Survey's project manager and science lead for NASA's Solar System TREX project, a set of online data visualization tools designed for mission planning, lunar and planetary science research, education, and public outreach. From 2010 to 2014, Brian served as the Education Public Outreach Lead for NASA's Lunar Atmosphere and Dust Environment Explorer mission to the moon, which flew through and studied the moon's atmosphere. From 2007 to 2010, he served as the Education Public Outreach Lead for NASA's La Crosse Lunar Impact Mission, which discovered deposits of water ice at the moon's south pole. He has participated in various NASA Mars analog field studies, providing technical support in the field of webcast and robotic rover tests in extreme environments here on Earth. In 2007, he flew the Aurigid MAC mission to record fragments of the comet Keys entering Earth's upper atmosphere. He studied astrophysics in college and graduate school. His work at NASA has stuck him into the fascinating study of planetary science, something he is quite happy about. Brian has taught at San Jose State University. He served as the chairman of the Foothill College Observatory for 16 years. He is a dedicated chaser of total solar eclipses and has traveled around the world to enjoy the rare treat of standing in the moon's shadow. Welcome, Brian Day, to Science Never Stops.
Thank you very much, Joseph. It's great to be with you and your audience.
Well, our first question, with today being International Observe the Moon Night, and we're celebrating around the world, what is your first memory of observing the moon and the impact it had on you now that you're a NASA lunar scientist or planetary scientist?
Well, I tell you, my parents used to tell me that when I was very young, before I could even walk, they'd carry me outside in the evening and I'd look up at the sky and I'd point up at the moon and the stars. I got my first telescope when I was in elementary school, and I remember setting it up out in the front yard and pointing it at the moon night after night. And each night, the view would change. The lighting on the moon would be different from one night to the next. New objects, new terrain would come into view, and things that I had seen the night before looked entirely different with the change of lighting angle. It was a never-ending show, and it captured my interest back then and has held it to this day.
Oh, that's great. Now, speaking of you looking and observing the moon as a child, and that has stuck with you going into adulthood, could you elaborate on the current lunar research and mission work you've done with NASA?
So right now, I'm very lucky to be involved in a project called NASA's Solar System TREX project. And this is a series of online data visualization and analysis tools that allow users to view the surface of the moon and other worlds throughout the solar system as seen through the eyes of many different instruments on many different spacecraft. This allows you to do some really amazing things. You can very easily measure the size of features. You can measure the heights of mountains, the depths of craters and valleys. You can draw a bounding box around any terrain you want and use that to generate 3D print files. So if you have a 3D printer, these things look great. You can draw a path you want anywhere across the surface, and it will generate a little QR code that you then scan into your smartphone, put your smartphone in a pair of cheap $5 Google Cardboard goggles, and whatever path you just drew, you will now fly in virtual reality. So we use this tool set and a whole bunch of additional tools that are built into it for mission planning, for planetary science and lunar science, but it's also a really great tool for students and the general public to get involved and really join us in studying where we're going on the moon, where we're going on these other worlds throughout the solar system. And that's at Trek, that's trek.nasa.gov.
So you could be your own virtual astronaut.
That's right. And I'm glad you put it that way, because one of the really cool things is you go into the 3D control mode, and if you're familiar with basic game controls on your computer, you can essentially go flying in real time over the surfaces of these worlds. So interactive flying over the moon, you go explore where we're going next, where we've been. It's a lot of fun.
Well, speaking of virtual astronauts transitioning into real astronauts exploring the moon, are you excited about NASA's future efforts of landing astronauts again on the lunar surface to explore the South Polar region, especially in Shackleton Crater?
Oh, absolutely, absolutely. So I'm actually old enough to remember all of the Apollo missions. I can even remember the Gemini and Mercury missions that led up to them. But on our Apollo missions where we landed, those sites, as fascinating as they are, and they really are fascinating, but they are dramatically different from what we are about to experience with Artemis. All of the sites that we went to in Apollo were essentially what we would call low latitude sites, fairly near the equator, all on the near side. When we go to the south pole of the moon, we're going to encounter something really different. The lighting conditions are going to be extreme. There are areas there that are in permanent shadow. The sunlight is coming in nearly horizontally. And so it'll skim over the tops of craters, and the rims of those craters will produce shadows. There are many craters near the poles of the moon whose floors have not seen sunlight in well over 1 billion years. As a result, these places, because they are so very dark and have been so for very long, are the coldest places we have yet measured anywhere in the solar system. And we now realize that these could be places where water ice has accumulated. That could be a hugely valuable resource for us. But at the same time, right next to these pits of eternal darkness, you have peaks that stick up into the sunlight and get nearly constant sunlight. So you'll have this interesting juxtaposition of brightly lit terrain and deeply shadowed terrain right next to each other. It's going to be very, very interesting. The nature of the lunar soil, the regolith that we encounter, will be very different from what we encountered in Apollo. We anticipate that in areas we may actually see ice mixed in. And the one thing we can certainly anticipate is whatever we find there, we are going to be surprised.
Now, with the moon's less atmosphere, extreme less atmosphere than what we're used to on Earth, and those lighted areas versus the pit of darkness areas in those craters, is there an extreme temperature gradient as well within those light and dark areas?
Indeed, indeed. So, so the typical place you go to on the moon, where we landed with Apollo, you would find essentially 2 Earth weeks of light, followed by 2 Earth weeks of dark. And those temperature extremes there were fairly great. You know, somewhere around 200 degrees above zero during the daytime and 200 below at night. But at the poles of the moon, these permanently shadowed areas can be just, a handful of degrees above absolute zero. And so that provides a real engineering challenge to going in and exploring those areas and perhaps retrieving resources from those areas. Fortunately, one of the things that we seem to be seeing is that perhaps that water ice is not limited to being just in those deep, dark, intensely cold shadows. But even in areas surrounding those permanently shadowed craters, areas that do get occasional sunlight, the sunlight is coming in at such a shallow angle, it doesn't do a great job of heating up the ground. And so there's the potential that in these areas that do get at least some sunlight, if we dig down a little bit, we could get to an area where water ice is stable. Mm-hmm. So we might be able to harvest water ice from areas that perhaps are not as extremely cold as these permanently shadowed regions. We don't know this for sure yet. This is one of the things that we need to determine. There's a critical process ahead of us here that is involved, any geologist and any person here on Earth involved in mining is familiar with: prospecting. We have to do this critical stage of prospecting, identifying where the resource is, how it is distributed, how concentrated it is. And so that's one of our upcoming, Artemis consists of, yes, these wonderful human missions coming up. The first woman and the next man to walk on the surface of the moon, but it also involves robotic missions that will be supporting it. And one of these will be the Viper mission that is going to be coming up soon. And this will be a robotic rover that will essentially scout out that terrain and map the distribution, do the prospecting of that resource of water ice.
Now, with more research will be needed to discover this, but in your opinion, what do you think that water that we discover, if we discover it there, harvest some, would that water, in your opinion, be potable, safe to drink water possibly for the astronauts to use?
Well, that's an excellent question. And back a little over 10 years ago, when we had the LCROSS mission, we were able to sample some of that water that had accumulated in a permanently shadowed region on the floor of the crater Cabeus, very near the South Pole. And what happened there is we took the upper stage of our Atlas V moon rocket, a Centaur upper stage, weighing about a couple tons, moving at 5,600 miles an hour, and slammed it into the surface of the moon, blasting a bunch of material off the floor of that crater, out of the shadows, into the sunlight. And then our little spacecraft dove down into that cloud of debris and sniffed it and analyzed it. And that's how we discovered that there was water ice indeed in there. But that water ice, we were able to do some really detailed spectral chemical analysis. And we discovered that it's mixed with all kinds of other stuff. There's ammonia. There are metals such as mercury. There's silver. There's all kinds of stuff. So you wouldn't want to just melt it and drink it.
Right.
It's going to require a little bit of processing.
All right. So at least it's there and available. But moving on, what is your favorite scientific moon fact you'd like to share with our audience?
Oh, wow, there are so many. When I was young and going to school, we learned that the moon was bone dry, it was geologically dead, and it was completely airless. All of those things were wrong. We now know that there are hundreds of millions of tons of water ice at the poles of the moon. We know that the moon does have an atmosphere. The Laddie mission actually flew through that atmosphere. It's very thin, very tenuous, but studied its composition, its structure, and its variation over time. And we know that the moon is, in fact, geologically active. As a matter of fact, the moon has moonquakes. It can get up to magnitude 5.5 and last for over 10 minutes. Let me assure you right here and right now, if you're in a magnitude 5.5 quake that is lasting for 10 minutes, you will quickly conclude that the object you're sitting on is not geologically dead. But we've also learned that the Earth and Moon are really intricately connected. We see that the solar wind streams the Earth's atmosphere, blows the Earth's atmosphere out in a almost cometary-like tail. And it does the same thing to the moon's atmosphere. And so once every month, the moon passes through our magnetic sheath and through this tail of our atmosphere. And once every month, we pass through this tail of the lunar atmosphere. And it isn't just an exchange of gases, but we actually find pieces of the moon. We find moon rocks here on Earth that have been blasted off the surface of the moon by meteoroid impacts and that fall here to Earth in the form of meteorites. And the reverse is also true. Recently we discovered, these rocks are fascinating things. Rocks tell us stories of how they formed, where they formed, when they formed, the conditions under which they formed. And of course, we would love to find rocks from the earliest days of the Earth to understand the beginnings of this planet that we are so dependent upon. But because of wind and rain and erosion and plate tectonics, we cannot find any rocks from the earliest days of the Earth. But it turns out that back in 1971 in the Apollo 14 mission, astronaut Alan Shepard was walking along and he saw a rock that he really liked. He picked it up, brought it back. And as that rock has been studied more recently, we find that it's composed of different rocks that were fused together in the heat and energy of a meteoroid impact. And one of those rocks within Big Bertha, the bigger rock, tells us a fascinating story indeed. It tells us a story that it doesn't seem to be a moon rock at all. It seems to be a rock that formed here on Earth between 4 and 4.1 billion years ago, but then got blasted off the surface of the Earth by a giant meteoroid impact. It flew through space, it landed on the moon. But it didn't get to rest there in peace very long, because then 3.9 billion years ago, another giant asteroid hit, formed the Imbrium Basin, and from the standpoint of our little rock on the moon, it saw this massive tsunami of bright melted stuff coming over the northern horizon and burying it and fusing it to the native moon rock around it. And there it should have remained buried for the rest of the time, but 26 million years ago, another meteoroid slams into the ground, forms Cone Crater, digs our little rock up, leaves it on the surface, where then Alan Shepard can come, look down, pick it up, and bring back to us the oldest Earth rock that we have ever seen.
That rock that you're referring to, I've heard it referenced as the Genesis rock.
Well, there was another rock called the Genesis rock from Apollo 15. So that was interesting because prior to that, we had sampled rock from the Mare terrain, the smooth basaltic lava plains of the moon. But that is younger terrain than the rough, rugged highlands, the lighter colored, mountainous. And again, this is something to look for on Observe the Moon Night. When you look through the telescope tonight, when you look through binoculars tonight, look for even with your eyes, look for the dark colored terrain and the light colored terrain. That dark terrain is the younger, solidified flows of lava that form the Mare units. The light terrain is this much older lunar crust that formed as crystallized froth floating at the top of an early magma ocean. And so with Apollo 15, it landed in some of that Mare terrain, but then they got in their little rover and they drove up to the slopes of Mount Hadley Delta, which was then the slopes of the highlands above. And they actually looked for some of this light-colored anorthositic rock that might have rolled down and become accessible to them. And they found it. They found an example of that. So that's this stuff that was much older than the Mare terrain that we had experienced so far. And so they brought back that wonderful piece of rock that was, to that point, the oldest rock we had seen on the moon, and that was called the Genesis rock. Later on, with Apollo 16, we actually had astronauts land in those rugged ancient lunar highlands. So, and Apollo 17, again, we explored the margin between the highlands and the Mare terrain. So we've seen a variety of areas. One other thing I'll point out about the moon that is really fascinating, this is fairly recent research, we see some indicators. I mean, as we look at the surface of the moon, because you don't have the erosion that you have here on Earth, you have this wonderful history that is very preserved for us. And if you read the landscape, it can tell you about the events that happened in the early inner part of this solar system where we live. And one of the things that we seem to be seeing right now is this interesting story of how about 800, let me get this right, 800 million years ago, there was apparently this shower of fragments of an asteroid that had been disrupted. It now forms the Eulalia family of asteroids. But you had this great big shower of rocks come pummeling into the inner solar system, slamming into the moon, forming a number of craters, large craters simultaneously, apparently. And we think that the same thing probably happened here on Earth. Now, 800 million years ago is a long time here on Earth, and the actual craters that might have been formed from that have long been erased by erosion and plate tectonics, but they're preserved on the moon. But one of the things that we do see on Earth that happened near that time was this onset of the cryogenian period. A dramatic change in the environment of the Earth. The sudden development of almost global ice sheets and a dramatic change in the abundance of life on Earth. This was a huge game changer for Earth. And so we can read events by studying the moon that could have had profound effects here on the Earth.
So it sounds as though the moon is a geologic time capsule for the Earth itself.
Absolutely, absolutely.
Well, where can our viewers go to learn more about the science you are currently doing and have done in the past with NASA?
Very good. Well, I'm going to recommend two sites right off the bat. Well, at least two. Let's say three. First, trek.nasa.gov. That's trek.nasa.gov to explore the solar system with us using these wonderful tools. You don't need to buy anything. You don't install anything. Just use your web browser and go for it. Also, go to servi.nasa.gov. That's SSERVI. And you'll get updates there from our various research teams across the country and around the world. And of course, everybody loves solarsystem.nasa.gov. You know, there's a fantastic resource for you there.
Well, thank you. And for our guests that are watching, what advice would you give as a current NASA scientist to the next generation of NASA scientists and engineers?
That's an excellent question. For the younger people, I would recommend, in addition to your studies at school, get involved with one of your local amateur astronomy organizations. Now, I have had the pleasure of visiting the Huntsville, Alabama area a number of times. I've got good friends working there. And I happen to know that there is a very active and wonderful amateur astronomy organization there. I would encourage that. For those who are further along in their studies, again, look at the Servi website, servi.nasa.gov. And one of the things you'll see is that we have an annual conference, the Exploration Science Forum, and all of the presentations for this last one and for previous ones are available online, as well as a number of online courses that a number of our researchers have taught. And finally, also, I'll point out that there are some great groups, online groups. One of the things that we sponsor is the annual Lunar Grad Con. And so if you're a graduate student about to make your big splash in the world of lunar science and planetary science, this can be a great way to network with your peers and to talk and interact with some of the leading researchers in the field now, you know, those people that you are about to replace. But I would just welcome you to take advantage of all these wonderful online resources.
Well, thank you very much, Brian Day, for joining us in our celebration of International Observe the Moon Night.
Thank you so much. I really appreciate it. I hope everybody has clear skies and exciting views.
Thank you for watching, and thank you again to our sponsor, the Planetary Missions Program at Marshall Space Flight Center. Please go out, observe the moon, as well as online to see other exciting virtual moon celebrations around the world at moon.nasa.gov/observe. Wishing you all clear skies, and remember, science never stops.